Okay, this is question 4 on your Mechanics 1 mock that you did. It's the January 2013 paper. Remember, we didn't have the mark scheme when we set this, so we can make our own mark scheme up. So I'm not going to spend too much time on where the marks are, but I am going to show you how to do the questions. Okay, so on this question, question 4, we have another acceleration problem, velocity acceleration problem, where the acceleration isn't constant. So we have a particle of p moving in a straight line, where t is time in seconds, and this time it's moving in a straight line, and it's told us what its acceleration is. Look, and it doesn't tell us what the acceleration is. Oh, it does. It tells you here the acceleration, but I was looking at the units there. And part 1 is worth 2 marks, so it's not going to be too much work for this. We've got to find the values of t for which the acceleration is 0. Well, we know that a equals t squared minus 9t plus 18, and we've got to find the values of that, where that equals 0. So basically, that's a GCSE solving a quadratic equations question. So hopefully you'll be able to solve that. Now you should always look to see whether it factorizes before you try and complete the square or use your formula. But don't forget you've got a graphics calculator, some of you, and you can also use your graphics calculator as long as you make it clear that's what you've done. So we're going to get t, oops, not t squared, t and t. And we're looking for two numbers that multiply together to get 18 and add together to give negative 9. So off you go, and factorize that please. Good, you should have got minus 3 and minus 6, or negative 3 and negative 6. So we know that acceleration is 0 when t equals 3, when that bracket equals 3, well that's when t equals 3, or when t equals 6. Nice 2-mark question for the beginning of that question. You should all have been able to get that one. Now part 2. It is given that when t equals 3 the velocity is 9 meters per second. Find the velocity of p when t equals 0. Okay, right. Well, we should know that the velocity is equal to the integral of the a function with respect to t. So I've got to integrate t squared minus 9t plus 18 with respect to time, and that will give us the velocity. So integrate that please. Right, well if you integrate that you should have got a third t cubed minus 9 over t 2t squared plus 18t, and this is the thing that a lot of students forget, the constants at the end. Now that's really important. Okay, now that's core 2, look back on your core 2, but you should always include a constant. Now basically we've got to work out what that k is, and they've given us the boundary conditions that when t equals 3 that p equals 9. So now we've got to substitute these values into this equation to find the value of the constant k. So v equals 9 meters per second. So I know 9 equals 1/3 of 3 cubed minus 9 halves of 3 squared plus 18 over 3 plus k. And now I've just got to work out those values, rearrange it to work out my constant k. You do the same please. And I get k is equal to negative 13.5. Hopefully you've got the same. So we now know that the formula for velocity is equal to 1/3 of t cubed minus 9 over 2 t squared plus 18t minus 13.5. So there's my velocity formula. So I'm going to put it into a box so that I can find it easily. And they want to know the velocity of p when t equals 0. So now we substitute t equals 0 in, and we get v equals negative 13.5 meters per second. And put it in another box. Okay. So that's part 2. Now the last part of this problem asks to show that the direction of motion of p changes before t equals 1. Well, we know the velocity equals negative 13.5 meters per second when t equals 0. So if we can find the velocity when t equals 1 and it's positive, then we know it's changed direction. It's only worth 2 marks, so always look at your marks. That should give you an indication of how much work you're meant to be doing. So we know that v is equal to, I wrote it down above, 1/3. So now we're going to substitute 1 in. It's as simple as that. And if that's a positive value, we know that the velocity has changed direction because it was going in one negative, so it's going in that direction. If it's negative, so it's going in that direction, it's positive. If this direction is positive. So put those values in and see whether you get a positive value. Now I get v equals 1/3, which more importantly, v is positive, so it must have changed direction before t equals 1. So I've just written that at the end. Okay, so that's the end of question 4.